Hello everyone, welcome back to Long EduTech, and today in the chemistry second day of the class 9, so we will discuss the more explanations for the properties of the solids and other remaining parts of the chapter. So for the more explanations for the properties of solids, so solids have a definite shape and a definite volume because the particles are packed by the strong intermolecular forces of attraction. As we discussed before, solid particles are very tightly packed due to the strong intermolecular forces of attraction. Right. And second, solids do not flow easily because the particles cannot move or slide over one another. Okay. And number third is solids are not easily compressible because there is little intermolecular space between the particles. As we know, with increase in the intermolecular forces of attractions, there is decrease in the intermolecular space or interstitial space also we call it. Okay, so due to that one, here solids are just say negligibly compressible because there is no space to compress. Okay, now we'll go to the more properties about the liquids. Okay, liquids are not easily compressible and have a definite volume because there is little free space between the particles as compared to the solid and also. Liquid flow easily because the particles can move or slide over one another. The particles of the liquid, they can move or they can slide over the another particles. That's why they can flow easily. Okay, now we come to the more explanations for the properties of gases. Gases are easily compressible. Why so? Because there is a great deals of the free space between the space. That means, as we know, there is the very weak intermolecular forces of attractions. You know, in gases, the weak intermolecular forces of attractions are also called as the van der Waals force. What force? Van der Waals force. Okay, and due to that weak intermolecular forces of attraction, there is a very large free space between the particles. That's why they can be compressed very easily, or we can say gases are very highly compressible than the liquids and solids. Yeah. Second point, gases flow very easily because the particles randomly move over one another. Randomly they can move one over the one another mediums. That's why they can flow very easily. That's why they always touch the wall of the container where the gases are placed. Next, gases have an indefinite shape and an indefinite volume because the particles can move over one another. Okay, from one place to another they can move over. Yeah, these are the more explanations for the properties of the solid, liquid, and gases. Okay, now we'll discuss about interchange in the states of matter. That means the particles or the matter can change its states from one form to another. So water can exist in the three states of matter. For example, this is an example. Water can exist. What are they? Solid. How? As an ice. Liquid as in water. And a gas as the water vapor. So like this three form, the water can exist as a solid, liquid, and gases. Vapor is in the gases form, right? Okay, now see the sublimations. They sometimes are here and we have to discuss the process of the solid directly into vapor on heating without changing its state into the liquid and liquids, okay, and vapor into the solid on cooling is called the sublimations. That means that solid directly can change its state to the gaseous when we apply heat or when we heat it. and again when we cool down the gases, that is the vapor, directly come back to the where solid forms. Without it stays to the liquid state. That means liquid they levitate. Okay, and directly solid to the gas, and the gas to the solid, they come back. Okay, and this process is called as the sublimations. What types of the matters cause the sublimations? There are ammonium chloride, camphor, iodines, and naphthalene ball. Naphthalene ball, that as an insecticide we use. You have seen that in the toilet or where we use the naphthalene ball disappear due time because they get heat from the surrounding and they directly vaporize. That's why the size of the naphthalene ball also decreases. And even used to recommend that the cap, or you say the place where we keep it should not be opened, because or should not keep nearby the fire, because the iodine that get sublime in the sodium chloride, that is in the salt, they undergo sublimation and they lose the iodines. That's why it is recommended not to keep all those salt bottle near the fire or keep opened. Yeah. Okay, and now we will discuss the effect of the change of the state of matter. Okay, effect of the change of the state of matter. Matter can change its state from one to another, as we already know. But how? By what conditions? That's only. So first one, we have to discuss the effect of the change of matter in temperature. That means the matter can change states while changing the temperature. Okay, so here, the temperature effect on the heating a solid varies depending on the nature of the solid and conditions required to bringing the change. Okay, on the solid, it depends on the nature of the solid, what types of the solid it is, and the condition required to bringing the change. For example, iron. For iron to change its state, it takes a lot of temperature. We have to heat above the 1000 degrees Celsius, right? And also to melt ice cube, here we don't need that much temperature, right? So it depends on the types of or the nature of the solid. Understand, right? Okay. And on increasing the temperature of the solid, the kinetic energy of the particle increases. The kinetic energy of the particle, that is, the kinetic energy is the energy due to its motion. When the particles of the substance or matter get energy, they have the tendency to move very fastly. That's only. Kinetic energy of the particle increase with, okay, and which overcome the force of attraction between the particle, thereby solid melt and get converted into the liquids. Okay. So here the temperature at which the solid melts to become the liquid at the atmospheric pressure is called its melting point. Okay, the temperature at which the solid melt, okay, to become the liquid at the atmospheric pressure is called its melting point. The melting points of the ice is 0 degrees Celsius. We can say at 0 degrees Celsius they get freeze also, at 0 degrees Celsius they get melt also. The melting point of ice is 273.16 Kelvin. That is 0 degrees Celsius only in Celsius scale. Okay, the process of melting, that is change of the solid state into the liquid state, it is known as the fusions, or just simply melting also we can say. Okay, and this melting is also called as fusions. Got a point? Okay, now we'll discuss the next, that is effect of the change of the pressure. Okay, so increasing or decreasing the pressure can change the state of matter. Applying pressure and reducing the temperature can liquefy the gas and solid carbon dioxide. Okay, solid carbon dioxide is stored under the high pressure, and solid carbon dioxide get converted directly to the gaseous state on decreasing the pressure to the 1 atmosphere without coming into liquid state. And this is the reasons that solid carbon dioxide is also known as the dry ice. Okay, solid carbon dioxide is also known as the dry ice. Okay, now, so here see, this is a diagram. This is a cylinder, this is piston, and here we fill the carbon dioxide. So at this time this is carbon dioxide gas only, and now we give the pressure on this piston, and here the carbon dioxide get changed into liquid carbon dioxide on further compressions, and we apply more pressure on this carbon dioxide. So here the liquid carbon dioxide get changed into solid carbon dioxide, CO2, and this solid carbon dioxide is called as the dry ice. So like this, the state of the matter can change by applying the pressure. This is a simple diagram that we can understand about this. Okay, now we'll go to the latent heat. Latent heat is nothing, the hidden heat which breaks the force of attractions between the molecules during the change of the state is known as the latent heat. As you know, when we boil water, when we suddenly open the cap of the kettle, then, or any pot, okay, so sometimes we used to get burns by the vapors of the water. Why so? It is used to say that vapor burns more severe than the boiling water at the same temperature. Okay, the vapor are more hotter. What it means in a simple way, in a simple word. Why so? Because it contains some hidden heat. The water boil at 100 degrees Celsius. But if we give more heat to the water, do you think that the boiling water temperature will raise above 100 degrees Celsius? No. The boiling water will remain as 100 degrees Celsius. But we are giving the heat to the water, boiled water. But where does it go? That heat, the extra heat we supply, that undergoes to the vapor. That means that in the vapor it comes, and that heat is called as the latent heat. That is the hidden heat. Okay, and which help to break the force of attraction between the molecules and get changes into its states. That is the vapor states, right? Yeah. So at this point we have to know, very important. And now in this latent heat we have two. First one is latent heat of fusion. Okay, so the heat energy required to change 1 kilogram of the solid into the liquid at its melting point is called the latent heat of fusions. The heat energy, how much heat energy, that will be there. Okay, the required to change 1 kilogram of the solid into the solid into liquid at its melting point. Okay, so that's called a latent heat of the fusions. Okay, now comes the latent heat of the vaporizations. So this also same thing, the heat energy required to change 1 kilogram of liquid in this time liquid into gas at atmospheric pressure at its boiling point. Before is 1 kilogram of solid into liquid, but in this case 1 kilogram of the liquid to gases at atmospheric pressure at its boiling point. Okay, that's called the latent heat of the vaporization. These two terms we have to know. Yeah, so these are very important. Okay, now we'll discuss the evaporations. Okay, so evaporations, it is very useful, and because of the evaporations only here, even we also, when we feel hot, we sit under the fan. At the time our body feel cool. How? It's due to the evaporation. That is the rate of evaporation increases. Okay, let's see now. It is the surface phenomenon of the change of the liquids into the vapor, that is gas, at any temperature below its boiling point is called evaporation. Evaporation can take place at any temperature. Okay, below its boiling point it takes place, that is the liquid changes into the vapor, that is the gaseous state. Okay, that's called evaporations. Okay, got a point? Yes, more topic we'll discuss about evaporation, no problem. Factors affecting the evaporations. What are the factors affecting the evaporation? First is temperature. How? With increase in temperature, more the number of the particles get enough kinetic energy to change into the vapor state. Example, cloth dry fast in sunlight. Why we dry in sunlight? Because sunlight contains heat, right? So due to that heat, when the sun's heat is more, then our clothes dry very fast, right? Because the heat, due to increase in heat, the kinetic energy of the particle, that is, particle will be the water molecules that increases present in the cloth, and then when they increases, then they get vaporized. They change its states to the vapor state easily, right? So this is the temperature. You must know that with increase in temperature, the rate of evaporation also increases. Got it? Next slide is about surface area. Here also the rate of evaporation increases with increase of the surface area. Okay, so we spread clothes, example, to dry faster in sunlight. Okay, we spread clothes when we dry in the sunshine, isn't it? So we don't keep as we after washing the cloth. Yes, we don't keep like that, right? We spread it. Why? Due to the increase in the surface area, the area where the sun's heat or the sunlight give the heat, it's also increased, right? Then the increased surface area, the rate of evaporation also will increase. For example, another example, if we take the glass of water, and another we take the same quantity of the water in the plate, and we keep in the sunlight, what do you think, which one will dry faster? The one which we place in the plate, because the surface area is more. This kind of question are applications type question we have to keep in mind. Okay, we'll go to the third point, that is the humidity. The air around us cannot hold more than a definite amount of water vapor at a given temperature. If the amount of water in the air is high, the rate of evaporation decreases. Okay, so during the winter time, as you see, the fogs and all, they're also water vapor only. And during the summer days and all, due to the rains, after a rain shower, we used to find that the water droplets in the atmosphere, and it make it wet also, right? So higher the contents of the water vapor in the atmosphere, it decreases the rate of the evaporation. Got a point? And the humidity is the amount of the water vapor present in the air. Okay, yeah, number third point. And number fourth, here we got a wind speed. Okay, what you do when you feel very hot, you try to go nearby the fan, isn't it? Yeah, so the higher the wind speed, the rate of evaporations also increases. So we feel cool when we sit under a fan. Am I right? Okay, and when there is very windy days, the clothes also dry faster, right? Because the winds, it will blow away the particles of the matters. Okay, and make it dry faster. Got? So with increase in the wind speed, the rate of evaporation also increases. These are the 4 factors which affect the rate of evaporations. Okay, so now let's discuss the evaporation's caused cooling. Here, the particles of the liquids absorb energy from the surrounding, okay, to gain the energy lost during the evaporations. For example, when we do the exercise, we do the heavy exercise, and what happens? That is our body sweat, isn't it? Our body sweated, right? And then when we sit under the fan or stay for some time, here we feel cold only, isn't it? So that means that the heat from our body, okay, so that is removed in the form of the sweat. With the sweat it comes out, okay, and when it is sweating, then here it try to gain energy, okay, from the surrounding, try to absorb the energy. That means that absorb means that trying to cool down, okay. That is with the sweat our body heat will comes out and they will get evaporated. And then to refresh the place here, the cold air from the surrounding, they comes in contact with our body. That is the absorptions of the energy, okay. And then here it makes our body cool. So this is the evaporation cause cooling, okay. So this is an effect of cooling, or cooling by evaporation, okay. Yeah. Now see evaporations versus boiling. We always think that evaporation also give vapor, boiling also give vapor, but they are the same? No. Let us see now. Boiling is the bulk phenomenon as a whole, okay. Particles from the bulk, that is the whole of the liquids, changes into the vapor states by gaining the energy, okay. This is the bulk phenomenon. But evaporation is the surface phenomenon, and here the particles from the surface gain energy to overcome the force of attractions present in the liquids and change into the vapor state. So this is the surface phenomenon, and boiling is the bulk phenomenon. It takes as a whole, it takes only on the surface. The evaporation takes only on the surface of the substance, okay. Yeah. So and next comes to the temperature scales. You see, this is very important, and here the SI units of temperature is Kelvin, and 0 degrees Celsius is equal to 273.16 Kelvin. So we take 0 degrees Celsius is equal to 273 Kelvin. Okay, 0 degrees Celsius is equal to 273 Kelvin. Kelvin is another scale. That you see, the temperature in Kelvin is equal to temperature in degrees Celsius plus 273. That means we can find out the temperature in Kelvin, degrees Celsius plus 273. And so Kelvin scale of temperature has always positive sign. Always we get a positive value. Hence, it is regarded as the better scale than the Celsius. And another one also there, Fahrenheit. Okay. And 0 degrees Celsius is also equal to 32 degrees Fahrenheit. Got it? Okay. So now let us see some topic here. Atmosphere. Atmosphere, ATM, is a unit of measuring the pressure exerted by the gas. The SI unit of pressure is Pascal. Okay, and also 1 atmosphere is equal to 1.01 into 10 to the power 5 Pascal, PA. The pressure of the air in atmosphere is called atmospheric pressure. And here the atmospheric pressure at sea level is 1 atmosphere and is taken as the normal atmospheric pressure. Okay, 1 atmosphere. So we are living here with a 1 atmospheric pressure. You know, if we go higher and higher, when the climbers, the rock climbers and the mountaineers, Okay, so when they goes up inside above the hills, then the pressure get decreases. Okay, and the inside our body pressure become more. That's why from the nose bleeding used to happens, because our body pressure is more. So our body at the sea level, at the normal level, our body pressure and our atmospheric pressure are balanced. That's why nothing happened to us. Okay, yeah. Okay, so some calculations will be there. Convert the following in Kelvin. Or questions: 40 degrees Celsius, 70 degrees Celsius, and 25 degrees Celsius. Now see answer number 1. Here temperature is 40 degrees Celsius, right? Then here we have to apply the formula. Kelvin is equal to degrees Celsius plus 273. Yeah, degrees Celsius given almost 40 plus 273, then together it comes 313 Kelvin. So this is simple. And number 2, here comes that 72 degrees Celsius given, right? Same thing, here we apply the formula. Then here it is 72 plus 270 only, plus only, right? Then here comes 345 Kelvin. And number 3 will be your homework. Okay, assignments. Yeah, and again let us learn to convert the following into Celsius, Kelvin to Celsius. Okay, some examples are given here. So the first one is here, temperature in Kelvin is given 398 Kelvin. So the formula is degrees Celsius equal to Kelvin minus 273. Okay, this formula you have to keep in mind. If you want to convert into degrees Celsius, K minus 273. So Kelvin is 398 minus 273, then how much it become? 125 degrees Celsius. Okay. Second one, 298 Kelvin. So same formula we'll use. Then the Kelvin is 298 minus 273. That comes to 25 degrees Celsius. Okay. So and number third one is homework. Okay, I think I hope you enjoyed the video, and this is the end of the exercise. Thank you all. Thank you.